Today I will be discussing the problem of the day of GFG, that is possible paths in a tree. Okay, so we have been given a weighted tree. So you know what is weighted tree, and obviously there would be n minus one edges, and you have to process q queries. You have to process q queries. So in each query, what you will be given is that you will be given a number x. Okay, so let me explain what is this number, what is the role of this number x. So you have to, for each query, you have to return the number of paths in which the maximum age weight is less than or equals to x. Means we have to count the number of the paths such that the maximum age weight that can be possible in that path should be less than equals to x. Okay. So now and path a to b and b to a are considered to be the same. Okay. So consider the case like this. This is the given tree 1 to 2, and the age and the weight is 1. It is weight, it is the first node, it is the second node, and this is the weight. Okay, and now 2 to 3 4. So and the query, only you will give one query, that is 3. So how many number of paths are there such that the maximum age weight is less than equals to 3? You can see, if I consider this path 1 to 2, so obviously the age weight, maximum age weight is 1, so which is less than equals to 3. So this is satisfying the condition. And if I proceed further like 1 2 3, 1 2 3, then the maximum age weight is 4, which is greater than 3, so it is not satisfying the condition. Similarly, if I consider this 2 to 3, then it is also not satisfying. Okay, so how we can do this? Similarly, if I consider the second case, now this is the second tree we have been given 1 to 2 3, then 2 to 3 the age weight is 1, 2 to 4 the age weight is 9, and then 3 to 6 the age weight is 7, 3 to 5 it is 8, then 5 to 7 4. So now if I consider there are only 4 paths. Okay, suppose if I consider for the query 5, x is equals to 5. So we have to count the number of the paths such that the age weight, maximum age weight in that path should be less than equals to 5. So let's count it. If I consider 1 starting as 1, 1 to 2, yeah, it is satisfying. Then 1 to 3, it is satisfying. Okay. Now if I you can see no further paths would satisfy, because if I move further, then the maximum age it would be 7 and maximum age weight would be 8 here. So it is not satisfying. So obviously we have got only 2. And now if I consider starting as 2, then 2 to 3, yeah, it is satisfying, because the maximum age weight is 1. Then if I move further, then it will also not satisfy. And the last one, that is 5 to 7, 5 to 7, yeah, it is also satisfying, because the maximum age weight is 4, which is less than equals to 5. So yeah, we have got only 4. You can also see the explanation here. Okay, for this one, 1 to 2, 1 to 3, 2 to 3, and 5 to 7. So I hope the question is clear to you. Now let's move toward the solution. So, and also if I just show you, the expected time complexity, n log n plus q log n, means obviously the number of queries can be up to 10 to the power 5. So if I just like apply brute force for each queries, even though I here you can get a hint that whenever the query is up to 10 to the power 5, so obviously you would have to think of something kind of big of 1 or big of log n for processing each query, for answering each query. So let's move on toward the solution. Okay, so if I say you that suppose there the if I am talking about the queries, okay, x1 x2 up to xq, where q is the number of the queries. Okay, now if I say you that yeah, this is the queries we have to process, and if suppose x1 and x2 is greater than equals to like, oh sorry, this is like this, that it is already sorted in increasing order. Okay, it is sorted in increasing order. So if I just say that the number of the paths that was satisfying for x1 will also satisfy for x2, the number of the paths that was satisfying for x2 will also satisfy for x3. I can say that, no, because if I found that the number of paths with such that the maximum age weight is less than equals to 3, then it will also satisfy. Suppose the number of paths was p1 for x1 and p2 for x2. So obviously p1 would be less than equals to p2. Okay, am I right or wrong? Because the maximum weight, if the number of the paths we having the maximum age weight less than equals to 3, then obviously it will also satisfy the condition for 4. So that's why this is one catch. Okay, now how to process each query in log n time, we would have to see that. Okay, so this was the given tree: 1 2 2 3, then 2 2 3 1, then 2 2 4 9, then 3 to 6 7, 3 to 5 8, and 5 to 7 4. So let's consider the x1 like x3 is equals to 5 for the third query. Okay, so what if I just say you that the number which the weights which are greater than equals to 5, obviously they are not of relevance to me for answering this query x3 is equals to 5. Like x the weight 9 is not relevant to me, the 7 is not relevant to me, 8 is not relevant to me. So if I just tell you that I have to find the number of the paths, then you would answer me, you would have got the intuition what I means to say, that this would be the modified tree. Okay, I should preferably say graph. So now whatever the number of the paths that this graph will have, obviously that would be my answer, because obviously the maximum age weight here is less than equals to 5. It is satisfying the condition less than equals to 5. Okay, so if I ask you the number of the paths in a tree, so what would be the answer? Like choose any two nodes. Okay, any two pairs. That would be the number of the paths in a subtree. Okay, that I can say. Like if I consider this only, then what would be the number? 1 to 2, 1 to 3, 2 to 3. You can see here that this could be the number of paths. So for the formula is like 3C2. We are choosing any two nodes out of 3. You can see 3 is coming also from this formula. So now, and from here the size is 2 and we are choosing two nodes, so only one path is possible from this tree. Okay, so I hope the intuition is clear to you what I mean to say here. I mean to say here is that I will only consider the ages. If I am processing for a query having weight x, then I will only consider the ages which are having weight less than equals to x. And that's why just remember, try to recall what I have explained before this. Like if I have solved for x1, and if I am going to solve for x2, so whatever the tree I have constructed, like this is the graph I have constructed, will also be will also be applicable to x2. Why? Because x1 was less than equals to x2. I have already told you that I will sort the queries according to the weights. Okay, so if I sort the queries according to their weights in increasing order, so that is x1 is less than equals to x2 is less than equals to x3 up till xn x cube. So I can say that whatever graph, like suppose I am creating a graph. Let me again tell you. Suppose I have sorted the queries. Okay, so if I tell you that I am maintaining the graph like that, the age weight is less than equals to x1. Suppose I am solving for x1. So whatever the graph would be like, whatever the weight here, it would be less than wi would be less than equals to x1. Now, suppose I have solved for this. You don't need to know how I have solved this. Just suppose I whatever I have done, but I have solved this. Now if I am going to solve for x2, am I wrong that if I say that whatever the graph which I have created for x1 will not be applicable for x2, am I wrong? Obviously the whatever the graph I have created for x1 would be applicable for x2, because the whatever wi is less than x1 would obviously be less than equals to x2. Okay, so this graph will be a sub graph of the new graph, that is there would be some other edges added to this graph, but the whatever the graph we have created will also be applicable for x2. So that's the main concept. Now the only thing left is that how we can maintain the graph. So you would have got the intuition that how we can maintain, like we can process the query in log n time also, and maintaining the maximum weight. So you should think of the, if you heard about the union find, so that then there you would have known that we can create group. Okay, we can create group satisfying some conditions. So that will be that we will apply in this problem also. Okay, so let's see the code, then you will be more clear what I mean to say. So if you don't know DSU, disjoint set union, then you should first learn that. Okay, so I am creating a class for the DSU. Then I am creating vector for the parent and the size, and also I will maintain the number of the paths. I am creating a constructor for initializing the parent and the size vector. So parent is equals to, if you had learned the disjoint set union, then you will obviously whatever I am doing will make sense to you. Okay, I'm initializing the size of each of the node as one. Now what I will do is that I will set the parent equal to that node itself. Pair of I is equals to I, and then paths is equals to 0. Okay, then I'll have to create the union function. B A is equals to find of A, means I am finding the like root of this group. Okay, B is equals to find of B. If A is not is equals to B, then only I will have to process size of A plus sorry, if A is less than B, then we have to swap it. Swap A comma B. Sorry, size A is less than size B, then we should swap A comma B, such that I am maintaining the size of A should be greater than equal to size of B. Now parent of B would be A, and like before that I would have also created the find function into V. Suppose I try to find the root of the node V. So if V is equals to parent of V, that means that this node itself is the root node of the subtree or group, whatever we can say. Okay, so now one thing that is left is that, suppose what let me explain you what I am going to do. Suppose this is 1 and 2, this group was existing. Okay, so what, and this was satisfying for some x, okay, less than equals to x, means it is a query. And now uh, for solving some x2, for some x2, uh, it may be required that we would have to like merge this, make a link between this. So now what is the size here? The size here is 4, and the number of the path that I have like already discussed 4c2. Okay, but since we are maintaining the number of the paths into a variable, so we would have to, like the graph had been modified, so we would have to neglect the previous results. Okay, so previously the number of paths were like here it was 1 and it is 2, so 2. So we would have to first of all, like paths, we have to subtract this 2 from the path, and then only we would consider, we would have to add the like answer from the new graph, that is this one, that is 4c2, 4c2. Now you would have like understood what I mean to say. Okay, so that I will do here. Paths minus equals to size of a into size of a minus 1 by 2. Then paths minus equals to size of b into size of b minus 1 by 2. Okay, and now after the, like I perform the union, this was the union part. I will have to like recalculate the number of the paths, update the number of the paths, that is paths plus equals to new size of a into size of b plus minus 1, sorry, size of a minus 1 by 2. Okay, now since here it is the private member, although you can say that I will make it public, but for the better practice I can say let prepare a getter function for that. So this will do nothing, that it will return only the paths. Yeah, so I have created the DSU. Now only thing which has been left is that to sort the uh, weights, to sort the weights in increasing order, and to sort the queries in increasing weights. So I have already discussed why I am doing so, because whatever the answer, whatever the graph we have created for x1, it will also be applicable for the graph when we are solving for x2. Okay, so that's why we have to maintain in increasing order. So I can say sort ages dot begin comma ages dot. Okay, and since we have to like sort according to the weight of the ages, so we will have to make a comparator function, that is bool compare vector int ampersand a vector int ampersand b. Now we have to just sort it according to the a of 2, that is the, that is storing the weights of each of edges. So this should be this. Okay, now since we are going to sort the queries, and obviously we have to return a vector corresponding to each of the queries, so we will have to also maintain the index of each queries, like for which, since we, when we would sort these queries, so the order would not be maintained. Okay, so for that I will create a vector of pair. Okay, let name it new queries. Okay, and what it would be size like n. Now for int I is equal to 0, I less than q, I plus plus, I can say new qi is equal to queries of I comma I. Okay, so what the role of this in storing this index, so that we can maintain like for which query we are getting this answer. Now we have to sort these queries also. New q dot begin comma new q dot end. Now we are ready for performing DSU. We have created an object, pass the size n. Okay, so now for auto ampersand it new q, so you can say index is equals to it dot second, and int weight, like the int x value we would get from it dot first. Okay, I am like initializing a variable I is equals to 0, so that uh, suppose if I have processed the ages till ith index for getting the answer for the x1 weight. So when I am creating the graph for x2, so the graph I have created for x1 would be subset of the graph we are going to construct for x2. So we will not do that it again. So that's why I have taken the index I as global variable. So I less than equals to, sorry, I n minus 1, because that will be the number of the ages, I plus plus, and there should be a condition here. What the condition should be: ages of I comma 2 should be less than equals to the current weight. So this is the condition. Like I will only consider the ages such that it will satisfy the condition, that is the maximum weight should be less than equals to x. Okay, so if it's so, then I can say d dot union, what, ages of I comma 0 comma ages of I comma 1. And finally we can just call, sorry, now this will the disjointed union will compute the answer, and we can say that now answer of index, that's why I have maintained the index. Okay, so this is the corresponding answer for that weight. Okay, so answer of index is equals to d dot get paths. Now I can finally return the answer variable. One thing I forgot to like do here, answer, now it would be fine. So let's run it and see whether it is working fine or not. What is happening? Ready for okay, so some compilation error are there. So 42 1. Okay. So whenever you create a class, you should like uh, also place semicolon there. Yeah, it is giving right answer. Let's submit it. Why it is like so? Let's see. Size n plus 1 means we are getting a runtime error. So find of size of ages, number of queries. Okay, and queries I and I. Okay, sorry, it would be q. It should be q. It might happen that the number of queries is less than equals to n. Yeah, so now the it has been accepted. So I hope that the answer is clear to you.